Now let us study the equations which are reducible to quadratic equations. That means originally the equations need not be quadratic, or they may not look like a quadratic, but by suitable transformations we can convert them or reduce them to quadratic equations and then solve them. So here are some typical techniques that we use to solve these kinds of equations. In that, the first one is the substitution method. That is, some terms in the equation we replace by another variable and get a quadratic equation. Another way is that we may need to square both sides of an equation if it involves the square roots of the radical sign. And another variety is that we may replace a recursive expression by the original term itself. So we will see the examples of all these three so that it will be clear. Now let's see the first example out of this. Now we have to solve this equation in which we see that there are two square root terms on the left hand side and right hand side is equal to 1. Now to solve this, we observe that in the two terms which are inside the square root, the first two terms, that is 5x square minus 6x, is common in both. So this is where we use the substitution method. That is, we replace this particular repeating expression by a new variable. Let's call it as say y. So therefore our given equation reduces to root of y plus 8 minus root of y minus 7 equal to 1. Now we have to solve this, and as we see that there are square roots involved on the left hand side, so therefore we must square both sides so that we can get rid of square roots one by one. So therefore on squaring we will get root of y plus 8 minus root of y minus 7 the whole square is equal to 1. So therefore we get the first square as y plus 8. Then the square of the next term is y minus 7, and the middle term is 2 times the product of two terms, that is of y plus 8 and y minus 7. This is equal to 1. So now on taking the negative root sign on the other side and bringing the 1 on left hand side, basically if you see the 8 minus 7 is equal to 1, so that will get cancelled with the 1 on RHS. Also we have y plus y, which is 2y, equals 2 root y plus 8 into y minus 7, so that we can even further cancel 2 from both sides. And now once again we square, it is we'll get y square, and here we have y plus 8 and y minus 7. So on expanding the right hand side we have y square plus y minus 56, that is equal to y square. So we see that y square also gets cancelled now, and finally we are left with y equal to 56. Now the y was originally 5x square minus 6x, so therefore let us replace that with the original substituted expression. So therefore we have 5x square minus 6x is equal to 56. So that is 5x square minus 6x minus 56 is equal to 0. Okay. So now on factorizing this, we will get the two factors as 5x plus 14 into x minus 4 is equal to 0. So that gives us the two roots, which is first root is x equal to minus 14 upon 5, and the another root is 4. And we have to of course verify that these two roots satisfy the original given equation. So now since we will find that both of these satisfy this equation, so therefore that is the answer. Now let's move ahead to the next question. Now here we have to solve this particular equation, 4 raised to x minus 5 into 2 raised to x plus 4 equal to 0. Now this equation apparently does not seem to be a quadratic equation as such, but then if we observe closely, we can see that this 4 raised to x is nothing but 2 raised to x the whole square minus this is 5 into 2 raised to x plus 4 is equal to 0. So now if we see that this 2 raised to x, if it were considered as a new variable, then this equation is nothing but a quadratic equation in 2 raised to x. So therefore let's call this 2 raised to x as y, so that we will get the equation as y square minus 5y plus 4 is equal to 0. So this clearly factorizes into two factors, which is y minus 1 and y minus 4 equal to 0. So which implies that y must be equal to either 1 or 4. So if y is equal to 1 or 4, it means that 2 raised to x must be equal to 1 or 2 raised to x must be equal to 4. So therefore we get x is equal to either 0 or x is equal to 2. So therefore the two roots of the given equation are 0 and 2. So that's how we use the substitution method. That is, we here also replace one of the particular expression by a new variable, which makes it a quadratic equation. Let's go to the next question. Now here we have to solve this equation, which is, we can see that it's of degree 4 because it's having x raised to 4 term. If we observe the coefficients of the various terms, we will notice that the first and last are same, second and second last are same, and there is a remaining central coefficient. So we see that the coefficients are same on, from both the sides symmetrically. So now here what do we do is, we try to combine the two terms as shown here. So 12x raised to 4 and 12 are need to be combined. Same for the remaining. But since we have to somehow reduce this to a quadratic equation, which we can easily solve, what do we do is, first we divide throughout by the degree of the central term, that is x square. So let us divide throughout by x square, so that we will get 12x square minus 56x plus 89 minus 56 upon x plus 12 upon x square. The reason for dividing by x square will be immediately apparent. Now by this, what do we do is, as we saw earlier, we have to club the first and the last term. So if we take 12 common from that, we will have x square plus 1 upon x square as common. Then we club the second and the second last term. So if you take minus 56 common, here we will have x plus 1 upon x common, and the last remaining term is 89 as it is, equal to 0. Now if we see the first bracket and the second bracket, we can definitely write the first bracket as nothing but the square of x plus 1 upon x, and from that we have to subtract 2 and minus 56 into x plus 1 upon x plus 89 equal to 0. So the whole purpose of this particular adjustment was that we could adjust the same particular expression in both of the places, right? So now what we can do is, we can call this particular expression, that is x plus 1 upon x, as say y. So we will get 12 into y square minus 2 minus 56y plus 89 equal to 0, right? So on solving this, we will get further as 12y square minus 56y plus 65 equal to 0. So on factorizing that further, we will get 6y minus 13 into 2y minus 5 equal to 0. So which gives us y equal to either 13 upon 6 or 5 by 2. So that means now we have to consider both the cases. That is, let's consider the first part, that is y, which is nothing but x plus 1 upon x. This is equal to 13 upon 6. So on solving this, we get the quadratic equation 6x square minus 13x minus 13x plus 6 equal to 0, which when we solve, we get the two roots as x equal to 2 by 3 and x equal to 3 by 2. Now similarly, if we consider the other possibility, that is y is equal to 5 by 2, so we will get x plus 1 upon x equal to 5 by 2. Now here also, if we cross multiply and get a quadratic equation, we will finally land up in the quadratic equation 2x square minus 5x plus 2 is equal to 0. And when we solve this, we get the roots of these equation as 2 and 1 by 2. So therefore the final answer is x can be equal to either these two or these two. And since original equation is of degree 4, we rightly got the 4 roots of that equation. Let's go ahead to the next question. Right, here we have to solve the equation that root of x plus 5 plus root of x plus 21 is equal to root of 6x plus 40. Now here we don't see any specific expression to substitute with a new variable, so we'll straight away solve this by squaring both sides and then getting a quadratic equation. So on squaring, we will get x plus 5 is the square of first term, x plus 21 is the square of second term, and 2 into root of x plus 5 into x plus 21 is equal to 6x plus 40. So on taking all the terms on right hand side which are without root, we will finally get root of x plus 5 into x plus 21 is equal to 2x plus 7, because in the process we'll have to also cancel the factor of 2 from both the sides whenever it is available. Now here once again we still have one root, so we have to once again square, so that finally the square root will get eliminated from entire equation. So therefore on squaring we get x plus 5 into x plus 21 is equal to 2x plus 7 the whole square. So therefore on expanding the brackets on left hand side and also taking the square on the right hand side, finally we will collect all the like terms and finally get the quadratic equation as 3x square plus 2x minus 56 equal to 0. So here we get the factors as 3x plus 14 into x minus 4 equal to 0. So which finally gives us the roots, that is x is either minus 14 by 3 or it is equal to 4. But once again, as we have seen, when we square, we are basically allowing more values of x to satisfy that squared equation. So therefore, although we got these two values at the end, we have to confirm whether both of these values satisfy the original given equation. Now here if we actually substitute, we will see that the first value, that is minus 14 by 3, does not satisfy the original equation. So therefore it's not the root, but x equal to 4 satisfies the given original equation. So therefore the only root here is x equal to 4. Now let's see the next question now. Now here we see a very interesting right hand side, that is it contains infinitely many terms, one inside the other. So x is equal to root of 6 plus root of 6 plus and so on up to infinity, that is there are infinitely many terms. Now here this is related to the third type of the technique to solve these types of equations, that is we see that the part of this particular right hand side is equal to nothing but the entire x itself. So therefore if we consider this term, since it is having infinitely many terms, it does not matter whether it is inside any particular square root. So this underlined expression we can replace back with x. So therefore we can write x is equal to root of 6 plus x again. So now here this is another expression equation which we can solve by just squaring. So therefore when we square, we get x square is equal to 6 plus x. So therefore bringing all the terms on one side, we have x square minus x minus 6 equal to 0, and you know it's now easy to factorize, that is it is x minus 3 and x plus 2 equal to 0, which gives us x is equal to either 3 or minus 2. Now once again we have to check whether these two values are really the roots of the given equation. Now when we observe the given expression, so the right hand side, since it contains all the positive numbers, that is 6 plus some root, and inside that we have again plus 6 plus everything. So in short the entire right hand side is positive. So we must choose the positive value of x. So therefore minus 2 is not the valid answer, whereas x equal to 3 is the correct answer of this particular equation.